All right, so now today we're going to talk about integration by parts. So integration by parts is a technique of integration that allows you to undo the product rule. So if you have two functions, u and v, both functions of x, so u is a function of x, v is a function of x, and you want to take the derivative of the product u times v, you know now that you're going to have the derivative of u plus times v plus u times the derivative of v. Okay, so you have that. So let's say that we want to integrate. So we can rewrite this in terms of differentials. So the differential of u times v is going to be v du plus u dv. And when I integrate on both sides, I can remember that the integral of a sum is the sum of the integrals, and I get that this one right here, I'm just integrating the differential, so I just get u times v is going to be the integral of v du plus integral of u dv. So if I subtract v du on both sides, I get that the integral of u dv is going to be uv minus v du. And this is what is called the rule of integration by parts. And it's extremely useful. Okay, so with that formula, let's just do a few examples. Let's start with an easy one. So for example, x sine x dx. So this simple example, we already kind of integrate with the techniques that we currently had. We know how to integrate the sine. We know how to integrate the x. But unfortunately, just like with the derivative, we needed a product rule. For integration, we also kind of just say, well, the integral of x is x squared over 2. The integral of the sine is going to be negative cosine. I put them together, multiply it out, and I'm done. That unfortunately does not work. So we need to use this form. So we need to pick something to be my u, sorry, and something to be my dv. V, he says. And how do I choose it? And you know, when you're doing integration by substitution, it's always hard to know which one to do. But notice here that you're going to need to take the derivative of u, because you're going to end up with a du, and you're going to have to integrate v. So which one is the easiest to take the derivative of, and which one is the easiest to integrate? Usually u is going to be the easiest to take the derivative of, because that's just going to be your dx. And then necessarily then you have to pick dv, because you need something to be dv. So my u is this, and my dv is this one. So whatever is not the u has to be the dv. And since I picked u to be this, dv has to be the whole thing, sine x dx. If I have the dv and I want to get v, I have to integrate both sides, or take my antiderivative there. So it's going to be the negative cosine x. That's going to be v. So now that I separated the parts in a convenient way, then I go ahead and write my formula. And so I get u times v. uv is going to be negative x cosine x minus the integral of v, this one right here. So negative cosine turns this into a plus. du is dx. Now that you did that, then you copy your negative x cosine x, and then the integral of the cosine is going to be the sine. And do not ever forget your plus c for your indefinite integrals, or your antiderivatives as we call them. And you have right there your indefinite integral Now, notice this we wouldn't have been able to integrate otherwise. If you take your derivative, you will see that you get back your x sine of x. All right, so now it's just a matter of doing a lot of examples to make sure that everything clicks. All right, so let's look at this one right here. So again, usually, whenever you have a polynomial factor, that's going to usually be your u, because you're going to be taking derivatives, and eventually you're going to have that the derivative of a constant is 0, so you're going to be going down until that term doesn't appear anymore. So I'm going to pick that to be u. And then I'm going to pick dv to be the rest. Now du, 2x dx, v, I have to integrate, but the integral of the exponential is the exponential itself. So I get that, and I can plug it in using my formula. uv, x squared e to the x, minus the integral of v du. So 2x e to the x dx. All right, and you say, well, I still cannot integrate. What do I do? Well, you have another product, so it's time for another integration by parts. So let's move over. Let's do the second integration by parts in this box here. And so I'm going to do u now is going to be my polynomial again, so it's going to be x. du is dx, and now dv is going to be the same. So I chose x to be my u, and dv is going to be e to the x dx. And so as a result, v is the integral of e to the x. So to go from here to here, I take the derivative. To go from here to here, I integrate, right? Just to make sure that we're on the same page. All right, so now I can plug that in for that one. So I'm going to continue over here to make it a little bit less messy. If you believe me, I don't know. So x squared e to the x minus 2 times, and I'm going to put the whole integral here. I'm going to use the same formula again, uv x e to the x minus the integral of v e to the x du dx. So just plugging everything into the formula. uv minus v du. Oh, it's a little chop there, but you can still see it. All right. I went too close to the sun. So x e to the x, and then minus the integral of the exponential, which is e to the x again. And let's put the plus c at the very, very end. Now it's a matter of we can factor out a e to the x from this whole thing, just to reorganize it a little bit. Whenever you have exponentials, it's nice to factor. So x squared minus, let's distribute, 2x minus negative plus 2 plus c, and we get our antiderivative by double integration by parts, if you will. All right, we'll do another example here, and we'll see how that goes. All right, so this one is a little bit subtle, because at the moment you see it's just one function. There's not a product of them, so you say, well, integration by parts, why? But what happens is we don't know how to integrate the natural log, but we do know how to take the derivative of it. So if we do u equals natural log of x, so that would be that. And then what is left? That's going to be dv. Well, the only thing that is left is dx. So you pick that to be your dv. All right, so let's see how that goes. So you know that the derivative, you can take the derivative of natural log, which is going to be 1 over x dx. So dx over x is going to be your du. Now v, you're going to integrate here, but when you integrate, you just get x. All right, so we put it together with our formula. uv is going to be x ln of x natural log, minus the integral of v du. But look how nice, because v is going to be x, du is dx over x, and that x that multiplies cancels the x that divides, and we just get x natural log of x minus the integral of dx, which is going to be x natural log of x minus x plus c. And that gives us the integral of the natural log.